on your final, you'll have a series of problems, and here's basically what you need to do. If you have depth versus time, you can write an equation for each line of your data set. So our equations would be 430. Of course, what we're doing is y equals at squared plus bt plus c. Now I'm going to write the c first because it goes into the matrix more easily. So I'm going to put it in the form c plus bt plus at squared equals y. Okay, so the equation here it would be c plus 20b plus 400a equals 430. Here you would have c plus 60b plus 3600a equals 300. Some of these numbers might be hard to read. Board's a little rough. But I would hope everybody at this point would understand what I'm doing. Okay, so writing out the equations, I'm not going to read them to you. And this has already been done, but in the review, I'll do a quick. Should be a plus. You would get these 5 equations, which lead you to the matrix equation AX equals B, where A is your matrix of coefficients. 1, well, let's just do the first column, all ones. Second column would be 20, 60, 110, 160, 210. Now don't do like a lot of people do, try to read these things off of the table. Write down the equations to make sure you're doing it right. Okay, so I'm getting these from the equations. The A coefficients would then be 400, 3,600, 12,100, 25,600, 44,100. So here's your A matrix. Your X would be the column vector ABC, the coefficients. And actually, I've done this wrong many times. It's easy to write that because that's the way I'm used to writing it. But if I think about what I'm doing, I realize that it's CBA because, of course, if you multiply this matrix by this vector, you'll have 1C plus 20B plus 400A. That'll be your first product, and that'll be the left-hand side of this equation. And same for each row. And then B would be your 430, 300, 180, 120, 80, representing the depths of the water. Okay, so as it turns out, there's no solution, okay? You can't solve, so you get the best fit. What would you solve for? You'd solve for X, because of course you know everything else in this equation. You want to find 3 numbers here, but you have too many equations. You would expect the 3 numbers, if you just took the first 3 equations, you would expect to get values for A, B, and C. Now, if you took the last 3 equations, you would get values for A, B, and C. You don't expect to get the same value values from the last three equations that you got from the first three, because presumably these are observed by people walking around in circles and counting and writing down numbers. There's no reason to expect that your data would be totally accurate, or even necessarily that your quadratic model would actually fit the situation. Although with the water coming out of the bottle, it fits extremely well. Okay, well anyhow, this is a system of 5 equations and 3 unknowns. You can't solve it. Okay, but you can get the best solution. And you do that by getting the x the CBA vector, the numbers that go in here, such that AX is as close as possible to that B vector. Now this gets us into the 4 basic subspaces, 4 fundamental subspaces. And depending on your course, if you're in the 2-credit course, I'll tell you how you solve this. You just do A transpose AX equals A transpose B. This gives you 3 equations and 3 unknowns for this particular situation. And as you'll find on the test, I give you this information. Okay, now there's some other questions that I ask. I ask that you show the 4 basic subspaces and so forth. But this is how you would get the best fit. And on the test, I don't ask anybody to actually solve this equation, because you could be multiplying a 5 by 5 or 6 by 6 matrix by its transpose, and that would take a while. It's unreasonable to ask you to do that. So what we do instead is we have this distance versus time data for the water stream that comes out of the bottle. Okay, so let me talk about this next.